Hey, welcome back to the channel where we talk all things engineering, technology, and finance. Before getting into today's content, make sure you hit the like button below and don't forget to subscribe to the channel so that way you're up to date on all the latest content that we post to our channel. And lastly, make sure you share the video with friends and family. As I always say, we don't want to hoard the knowledge for ourselves and we want everybody to learn. So let's jump into today's content. Welcome to this week's content on inspiring you to become an engineer and tackling some of the tough challenges that we experience in the world. Today I'm going to share with you a project that I worked on a couple years ago, and the project had to do with malicious file classification. If you don't know by now, the world is moving digital. With this move to a digital environment, yes, a lot of great things come out of it, but also too, unfortunately, a lot of bad comes with it. So some of the bad things that we've seen is malicious files that wreak havoc on people, businesses. Sometimes they steal somebody's identity. Sometimes they wreak havoc for businesses and disrupt their way of doing business, causing them to lose out on revenue. As you're gonna see in the video, this problem grows exponentially. And unfortunately, we don't have the resources, and we're gonna touch on that in the video as well, to just throw so much at the problem. We only have a finite amount of people, money, time. So this project is going to show you some of the clever ways in which we engineers can tackle the problem. You're going to see a program that I wrote a couple years ago, and the program is a classification program that analyzes files, and it's going to tell you whether the file is malicious or not. And this prototype was written using a couple of technologies. What you're going to see is shell scripting, Python, machine learning algorithms, and this was all developed in a Linux environment. So you're also gonna see a little bit of Linux as well in there. All these different technologies were combined together in order to solve the problem, which is creating powerful features in order to classify whether files are malicious or not. And you can use this in order to defend your network either at home or in a business setting. So let's take a look at this project that I worked on a couple years ago, and hopefully, based on what you see, it inspires you to become the next engineer and tackle on these difficult problems that we experience in the world. Let's take a look.
My presentation is on automated malware analysis. So let's dive right in. One of the biggest problems that we're facing in the industry, and as you see based on this chart here by E.T.F, is we look at from 2010 all the way till today, 2019, we see a massive increase in the total malware produced each year. So if you do the mathematics behind it, it's about 1,804% increase from 2010 all the way to 2019, so about 200% year over year. That poses a big problems for people and organizations. We all have limited resources, whether it's time, money, people, or equipment. It's just such a massive problem, and we can't just dump as much money as we want into it or put as many people to it. We have to get smart and we have to combat the problem somehow. Here's the solution that I'm proposing: automated malware analysis process. This is broken up into two stages, as you see on the right. The first stage is what I call automating the boring stuff. If we take a look here, this is all tools that we can use to basically tie in everything together to determine the file type. Once you do that, you can generate the file signatures, use the file type or the file signatures in order to do virus scanning, and then you can determine if the file is obfuscated or not. If at any point, and you can follow the flow here, if it fails, it'll generate the report and say, hey, you're going to need to do some manual static analysis. But typically, if it goes through the process, right, it'll go and pretty much generate the report, all the information that you need, and that's all automated using glue code. But really, the bread and butter of this proposal here is really in stage 2. This is when you can't figure out what this file is in particular, and what we're going to use is we're going to use machine learning in order to do classification. So two of the biggest concepts is KNN, so that stands for K nearest neighbor. That's the machine learning algorithm that we're going to use, and we're going to also use another mathematical formula called the Euclidean distance, and that's basically going to tell us how far away the file in question is from its neighbors. Because if we were to plot on a graph where all of our files are, you and I can determine that, but a computer obviously can't do that. So we're going to use this mathematical calculation in order to let the computer figure out what that looks like. And then the other portion that I wanted to highlight about this architecture is the architecture implements the data science lifecycle. And so if you're asking, what is that? So let's take a look at that. The data science lifecycle is you're going to do capture, maintain, process, analyze, and communicate. When we look at all these nice fancy words, we say, well, how does that apply to your solution? This is what the stage 2 details look like and how it applies to the life cycle. So we're going to get our virus database in order to compare against, right? So that's our capture stage. After we've captured and have our virus database, we're going to go into the next stage, which is the sorting. Take a look at all the files we have and we're going to sort them accordingly. In the next stage, we can sort by HTML, exe, PDF, whatever the file type is. So we get a good representation of what that file is. In the next step, so the process, this is again what I was mentioning before, the bread and butter. Our cybersecurity experts, they're really going to spend their time on creating features. So these features are what they're going to use to look at a file and determining if they match these features. And we're going to come up with strong features because they're specific to that specific group of files. Once you create the features, we move on to the next one, which is analyze. We're going to run KNN algorithm and we're going to calculate the equality and distance based off of those features that we created. And then once you have that results, then you're going to go into what's called the decision process, right? So we're going to look at that and we're going to classify whether it's malicious or not. And then we obviously communicate the results with higher up. Given the amount of time that we had for this presentation, I went ahead and took screenshots because it's hard for me to show you downloading 65,000 files. Believe me, it took a long time. This is a script that I wrote that automatically went out to the web and started downloading clean websites that I can use for a database. And then also as well, as I mentioned, I went to Virus Share and I downloaded a torrent of 10 gigs, which was about 65,000 files. And I used that torrent in order to have my malicious database. And that is what I used to sort. So if we move on to the next screenshot, you can see here that this was another piece of code that I wrote in order to go in and take a look at all the files that I have. Here's some HTML, there's a TXT, XML, so on and so forth. And it went in and it organized the data for me. Right, let's go into a live demo. So here I have a Linux machine that I've remoted into. It's sitting on my network and it houses malicious and non-malicious database, as well as if you take a look at amount of scripts that I wrote a couple of scripts in order to make this whole process work. Here is the database that we have of all the different files, file types. And then here we're going to go ahead and run the actual result. If we actually take a quick look, just to show you that I have things working here, I put a file called, let's see, HTML in question. So this is a directory. And if you notice, I have here verizon.com. So we're strictly dealing with HTML. Maybe I forgot to mention that, but we're strictly dealing with HTML files for this presentation. Here we have verizon.com. So what I'm going to do is I'm going to actually run my application against that. We're going to see the results of that. All right, perfect. So what it does is it does two things. It does the equality and distance, and it shows you all the mathematical computation in a nice report for you to review. So it tells you if the file is malicious or not. And then not only that too, it actually plots it visually so that way you can see. So if we actually take a look, we can see here that here are the three things that I have. So I have malicious for blue, non-malicious in green, and the file in question is in red. So if I want to, I can go around here and I can actually see what my data looks like. So I see here the features that I picked for this particular presentation. I'm going to take a look at the number of SLOCs, right, source lines of code, the number of social media hits, and the number of profanities that is used, right? So those are basically three example features, but obviously we can create stronger ones. And we've noticed that verizon.com lands right in the realm of where all the other websites, as you notice from my other screenshots like YouTube, Facebook, and all that good stuff, it lands right in there. So we can actually see that it classified it correctly. So now, how do I know, this is working correctly and I didn't just make sure that that worked? Or what we can do is I'm going to go ahead real quick and move this malicious known file that I have in there. And then I'm going to say HTML in question. I'm going to go ahead and remove Verizon out of there. Now let's go ahead and run this again and see what we get. So as you notice, it says here file is malicious, and it's smart enough even to update the graph as well. So you could also see that it's changing everything dynamically on the fly based on the decisions. And you can also go ahead in here and take a look at where it lands. And you can see here that it's very close to all the malicious files that it resembles.
There you have it for today's content. Remember, Don't forget to like the video and, as we mentioned, subscribe to the channel so you're up to date on all the latest content that we post to the channel on all things engineering, technology, and finance. Finally, don't forget to share the video with friends and family. We always say this, we don't want to hoard the knowledge for ourselves. We want everybody to learn. So make sure you share the video with friends and family, and we'll see you on the next video.